Alright, so this video is going to walk you through how to solve a system of equations where you have two coefficients of the same variable where one is a multiple of the other. So if you can see, 6 is a multiple of 3. So when this happens, this is the process that you're going to take. So remember, your goal ultimately is to get one variable to eliminate. You want to solve for both variables, but you cannot solve for both of them at the same time. So you need to get rid of one of them so that we can then solve for the other. Okay, so we're going to try and get rid of the x by making the coefficients opposites of one another. So 6 is a multiple of 3, so you have to ask yourself, well, what can I do to 3 to get 3 to be the opposite of 6? And by opposites, we just mean the same number with different signs, right? So the opposite of 6 is going to be -6. So what can I do to 3 to get it to be a -6? And you're going to be multiplying it by -2. Now remember, in order to keep the equation balanced, you have to multiply that -2 by everything in the equation. So you can't just multiply the 3 because that would change the equation. You need to multiply the whole equation by -2. So when I distribute this -2 to everything inside the parentheses or to my whole equation, it gives me -6x plus 4y equals -32. Okay, I didn't do anything to my second equation, so that equation is just going to come down exactly how it is. Okay, so now I have two equations where the coefficient of one of the variables, in this case x, are opposites of one another. So what you can do is add the equations together. Okay, and by adding the equations, I'm going to add my x's. So -6 plus 6 gives me 0. They cancel out. I'm going to add my y's, so 4y and 5y is 9y. And I'm going to add my constants. -32 plus 14 is -18. Okay, so you see what it did was it allowed us to eliminate the x's, so now I can just solve for y's. The 9 is attached to the y by multiplication, so I'm going to divide by 9. And I end up with y is -2. Okay, so now that I know my value of y, now I can pick either of these two equations at the top. I'm going to substitute the y in, the -2 for y. So I have 3x. I usually just use the top one, but whatever equation has easier numbers for you, you can use. And now I'm going to substitute the -2 in for y. Okay, and now I'm going to just solve for x. So I have 3x plus 4, -2 and -2 is a positive 4, is 16. Subtract my 4 on both sides. Of 3x is 12, and then divide by 3x is 4. So remember, your solution to a system is a point. So it's not just an x value and a y value, but it's the point that has the x and the y together. So my solution in this case is is 4, -2. Okay, you do want to make sure that you always check your solutions, and the checks are super easy. You're just going to take each of your equations. So I have 3x minus 2y is 16, and my solution was 4, -2, where 4 is the x and -2 is the y. And I'm just going to substitute them into each of the equations to make sure it gives me a true statement. Okay, so I have 12 plus 4 is 16, so 16 does equal 16, so this is a true statement. Remember, your solutions give you a true statement when you substitute them in. And then my second equation, I have 6x plus 5y is 14, and I'm just going to substitute my values in again. So I have 24 minus 10 is 14, so 14 equals 14. So my solution works for both equations, which means it is a solution to the system.